Welcome to the International Conference on Smart Technologies and Applied Research. This is Basma Bashiri from the Laboratory of Advanced Material and Process Engineering of the University of Ibn Tufayl. So this presentation will take us on a journey through sustainable processes, addressing the importance of electrodialysis technology in material processing. So by the end of this presentation, it is my hope that you will gain a deeper understanding of the profound impact that electrodialysis can have on material processing and on the potential that it holds. Thank you for joining me, and let's start. In our time together, we'll talk about the several key reasons of sustainable material processing, the different separation and purification processes, electrodialysis, some examples of its application in material processing, and we will also examine the challenges and limitations of this technology. Sustainable processes have emerged as a cornerstone of 21st century developments, paving the way for the strong need to reconcile economic expansion with environmental protection. So adopting sustainable methods in material processing is critical for addressing global issues like climate change, resource depletion, and social inequity. So in material processing, sustainable processes are of paramount importance due to several key reasons that are innovation, reduction of environmental impact, energy efficient, cost saving, global responsibility, market demand, and resource conservation. So the separation and purification processes are integral components of material processing, and they include raw material refinement, concentration, impurity removal, size separation, chemical separation, recycling, quality control, and finally membrane processes. This is going to be our subject today, since we are going to talk about ion exchange membranes. Ion exchange membranes have seen exponential growth used in process engineering, and they play a crucial role in environmentally friendly technologies. So electrodialysis uses ion exchange membranes under the application of a direct electric current by producing an enriched solution, an ion-enriched solution called concentrate, and the depleted ion-depleted solution called diluate. So the basic units of ED is a cell pair with the diluate compartment, concentrate, an ion exchange membrane, and an anion exchange membrane, and a cation exchange membrane that are placed simultaneously. The principle of electrodialysis is that cations migrate to the cathode, and anions migrate to the anode. So once migrating, they are going to pass through anion and cation exchange membrane. So the role of cation exchange membranes is that it retains cations and allows anions to pass through it, and vice versa. The anion exchange membrane retains anions and allows cations to pass through it. So different electrodialysis processes exist, such as reverse electrodialysis or electrodialysis reversal, bipolar membrane electrodialysis, deionization, and many other processes. So the benefits of electrodialysis, it doesn't use any organic solvents. There is no hazardous waste formation, decreases the pollution loads. It's a long-term sustainability process. It helps in the water conservation, but also it is important in the materials recycling and recovery. So as an example of material processing, we have brine mining that involves the extraction of valuable minerals and compounds from sources, and as an example, from seawater or wastewater treatments that produces a lot of brines. So by using electrodialysis as a technology, we can ensure the production of salts and metals such as potassium, but also metals such as calcium, magnesium, and lithium. And lithium is an example that has been studied in a lot of works, and it is known for its physical and chemical properties. It is the most popular material in the battery industry, and over the next decade, the global demand for lithium is predicted to reach 3.8 million tons by 2035. The second example is the carbon capture and utilization, which is also important for sustainable processes. So the carbon dioxide is generated whether from industries but also from oceans that source 120 times as much as carbon as the atmosphere. So the carbon capture consists of the capture of carbon dioxide emissions before they are released into the atmosphere. Finally, we have the carbon utilization, that is the conversion of carbon dioxide in added high products, whether directly or indirectly, such as fuels, chemicals, but also into biological conversion. So several studies has investigated the use of bipolar membrane electrodialysis to capture the dioxide carbon, but also it was used in the carbon utilization. Finally, we have the rare earth metals recovery. So the demand of these metals as key materials is knowing an important increase all over the world. So they allow things to be smaller, lighter, and are used in everyday technologies. So they are key materials in medical technologies, electronics such as computers, cell phones, green technologies such as electrical vehicles, but also in defense application for satellite communication, but also in guidance system. So many studies have explored the separation of rare earth metals, such as the study that achieved the separation of lanthanum and europium. But also ED was used to separate dysprosium from neodymium plus praseodymium, and that achieves a separation factor of 125 using a chelating agent. So ED technology faces a lot of drawbacks, such as high energy consumption that is considered as the #1 trade-off of ED technology. So membrane fouling that reduces the efficiency of the process, the high capital cost, the competition with other separation and purification technologies such as distillation, adsorption, lack of rigorous economic analysis to determine the viability of the technology as a sustainable process. Finally, to summarize ED, ED is used to separate byproducts with high quality, high purity results. Combined with other methods can be both economical and environmentally friendly. It provides efficiency in lowering chemical usage, conserving water, promoting clean energy production. So the advances in membrane material system design and energy efficiency are ongoing, addressing some of its limitations, expanding the technology range of application. And thank you for your attention.